Today's lesson 2.5 will be over exponential word problems, specifically simple and compound interest. Before we start, pause the video and complete the warm-up 2.20 in Delta Math. All right, do you have any interest in interest? It's time for us to start looking at how interest is calculated and try to come up with some answers from word problems. Very few banks today pay interest based on the simple interest formula. Instead, they pay interest by using a principle called compounding. So we're going to look at that more specifically. The difference between simple and compound interest is this. Simple interest grows slowly. Compounding speeds things up. So here's how it works. Simple interest is interest on the principal amount. The principal amount is what you start with. Compound interest is when your principal and any earned interest both earn interest. So we're putting the interest on top of the principal amount every time we calculate that interest. So let's consider this example. You begin with $100. You're investing it at 10% annual interest. So that means every year they're going to add 10% on. So in year one, with simple interest, you would have 100 plus 10 more dollars, or $110. Now, compound interest after the first year is going to be the same because we only have one time interval in 1 year. Let's look at 2 years. After 2 years, simple interest is going to give us $120. In other words, $10 on that initial amount each year. But with compounding interest, it's going to be $100 plus 10 the first year. The second year, they're going to give you 10% on that $110, and that's going to add up to $121. So we're a little bit ahead in year two. Let's be patient. Let's go to year three. Year three, simple interest, we get another $10 that third year for $130 total. Compound interest is going to give us $133. Year four, $140 in simple interest. Compound interest is going to be $146. Year five, $150 for simple, $161 for compound interest. Year 10, so we're going to skip 5 years, go up 10 years. We're going to have $200 in simple interest with that initial $100 amount. With compound interest, we're going to be up to $259. After 20 years, simple interest is going to give us $300 on that initial amount principal of $100. With compound interest, we're going to be over double that at $672. And after 50 years, simple interest would be $600. Compound interest, we would have $11,739. Compound interest wins. Sometimes you have to be patient. You don't see it right away, but this is exponential growth. From this example, it's easy to see that if you're saving money, you would prefer compound interest. Now you can model exponential growth with compound interest with the function below. So let's break this down, study it carefully. All right, here's your formula. I want you to write this down in your notes. A stands for the final amount that we're going to get once we calculate our interest. P is the principal, or the initial amount. You'll hear me refer to that as principal or initial amount. R is another variable in our formula. It is the interest rate, and we write that as a decimal. So if they give it to you as percent, we need to be able to convert percent to decimal. T is always going to be our time, and our time is calculated in years. N is the number of compounding periods. Now, we looked at an example with, we talked about annual. That's going to be one compounding period per year, annual. But if we talk about monthly, that N is going to change to 12 because we're compounding 12 times a year. N is the number of compounding periods per year, and that's going to end up in two places. So pause, take a minute to copy this formula down, make sure that you understand the pieces. So let's look at this table. If we say annually in our word problem, N is 1. Monthly, N is 12. Semi-annually, we're breaking a year into two pieces, so N is equal to 2. If we're talking about weekly, we have 52 weeks in a year, so N is 52. Quarterly, N is 4. Daily, N is 365 because we have 365 days in a year. All right, let's take a word problem and let's use this example to work through this with our formula. So we have $650 and we want to invest it at your local bank for 5 years. The bank has offered you two options to invest your money: 3.8% compounded semi-annually or 2.7% compounded weekly. The more often you compound in a year, the quicker your money is going to increase. But we have two different interest rates. Okay, the first one, semi-annually, we have a higher interest rate. Would that actually end up with more money at the end of the year? Let's check and see. Here's our formula. So we're going to take our amount, or A, our total amount, is going to be our initial amount, or our principal, $650, times 1 plus our rate is 3.8%. So we're going to be moving that decimal two places to the left. 1, 2. We're going to fill that in with the 0. It's going to be 0.038. Is the same as 3.8%. So we're going to replace that R with 0.038. N is going to be 2. Semi-annually is 2. We're only doing that first one, number 1. And then 5 is the time. Time is always in years. And that 2 also goes underneath the percent in the denominator of that fraction. So when you set that up carefully, get your calculator out, put those numbers in, make sure that the parentheses are where they should be. When you calculate that, let's go ahead and multiply 2 times 5 in our exponent. So 1 plus 0.038 divided by 2 is 1.019. I'm trying to simplify this a little bit before I put it in the calculator. You don't have to do that. Just want you to see what you can do. And we're going to end up with $748.61. So go ahead and try putting it in your calculator. Learn how to use your calculator with this formula. Don't make it hard, make it easy. And if you see any mistakes, reach out and let me know. Or if you need help in learning how to use your calculator, let me know. But practice with your calculator. Now let's go to number 2. Number 2, we're going to have the same formula, but our interest rate changes. We're going to have to change that percent to a decimal. So remember, move your decimal in percent, move it to the left 2 places. You're going to have a 0 to fill in, so that's going to be 0.027. Weekly, we have 52 weeks in a year. Our time is still 5. We still have 5 years. So we're going to replace that formula with these new amounts, do the calculation, and we get $743.92. So yes, the 3.8% semi-annually ends up being the larger amount. And that's because 3.8%, a full percent, a little bit more than a full percent, is going to actually give us more money with that amount invested. All right, now let's answer the question. Which option is better and by how much? So we need to take the larger amount, subtract the smaller amount, and it's that first option, 3.8% compounded semi-annually, is the better option by $40.69. All right, another example. Emily got some money from her college graduation and would like to invest it into an account for 8 years that has 7% interest rate, and money will be compounded monthly. How much does Emily have to initially put into the account so her investment will be $2,100? So we're asking a little bit different question. So read through the problem, get a general idea of what it is, highlight the important information, and let's put it all together. So now we have the final amount. We have A. We want her investment to end up being $2,100. So we're going to substitute that in, $2,100 for A. Okay, we want to know how much she needs to invest. So we are looking for P. Okay, that's going to be the variable that we have to solve for. All right, let's finish putting in the information that we have. Our interest rate is 7%. We're going to convert that to 0.07. Our time, 8 years, is going to be part of our exponent. And we're going to multiply that by n, the number of times that we're compounding within a year. So look at your word problem. It says monthly. How many months in a year? There are 12 months in a year. So we're going to replace that in this formula. It goes in two different places, in the exponent and in the denominator. Once you have this set up, okay, we're going to get this. I'm going to go ahead and simplify 0.07 divided by 12. And I'll multiply 12 times 8 to get 96 as my exponent. Now we're solving for P. So we need to divide both sides by 1.0058333. You get the idea. To the 96th power. This didn't actually come out real nice on the slide. So remember, we're dividing both sides. Let me see if I can get my pen. I don't have a pen, but work through this carefully. This is 1.005833333, okay, to the 96th power. We're dividing both sides by that. So 2100 divided by 1.005833333 to the 96th power. Okay, and we should get our principal at $1,201.49. All right, here's another example. Let's read through the problem. John invested $500 into an account with a 3% interest rate that's compounded quarterly. Okay, remember quarterly is 4, n is going to be 4. We want to know how long it will take for his investment to double. All right, so read through that carefully. We want to end up with an amount of double $500. So 500 times 2, that amount we're looking for is 1,000. Our interest is 3%, so change that to a decimal. Quarterly, our n is going to be 4. Let's put that all together. So we want $500 to double. We want to get 1,000. We start with $500, convert our percent, our interest rate, to a decimal. Remember, quarterly is 4, so 4 goes in the denominator. It also goes in the exponent. And then we want to know how long. So our variable this time is t. We're looking for t. And I hope you know where this is leading. When we're solving for an exponent, we have to use logarithms. Let's simplify this a little bit. 1 plus 0.03 over 4 is 1.075 raised to the 4t. So we have 1,000 equals 500 times 1.075 to the 4t. Now to solve this, we're going to divide both sides by 500. Remember, we're trying to isolate that variable t, which is in the exponent. So we end up with 2 equals 1.0075 to the 4t. Okay, we can bring that power over to the left using our log rules for exponents. And we're going to take the log of both sides. So log of 2 times 4t times the log of 1.0075. Okay, now we're solving for t, so divide both sides by everything that's not t, by 4 log 1.0075. Okay, and then we're going to be left with t equals log 2 over 4 log 1.0075. Put that in your calculator, and we should get 23.1914415,162. So practice. And if I make any mistakes, don't panic. Reach out and then let me correct those. But I think this is the right answer. So let's see if we've answered the question. How long will it take for his investment to double? So this is going to be approximately 23 years. If I'm rounding it off to the nearest year. If I'm rounding it to the nearest hundred, it's going to be approximately 23.19 years. So now when you're talking about years, it's going to be 19, we've got to convert that time. 12 months in a year, we've got to decide how we're going to convert it. All right, I rounded it to the nearest tenth. So time is 23.2 years. When we're talking about word problems, we need to make it make sense. All right, let's look at another example. We can find any piece of that formula that's missing. So let's read through the problem and try to think about what it's asking us to find. After receiving her business degree from UNC Chapel Hill, Kaylee is offered positions with 2 different companies. Company A offers her $80,000 per year, while Company B offers her $60,000 per year with a 4% increase every year. After how many years will Company B salary be higher than Company A? Let's break this down. We're still using the same formula. A, the total amount, equals P, the initial amount, times 1 plus the rate over the number of compounding periods. All of that raised to the number of compounding periods times T, the number of years. There's our formula. Let's plug in what we know. So we've got 2 different scenarios. Company A, we start with $80,000 per year. Company B starts with $60,000 per year. Okay, so let's look at breaking this down. Let's look at Company B. After how many years will the Company B salary be higher than Company A? So I just started with Company B, plugged in the initial amount, plugged in the number of compounding periods. Now notice we're not breaking the year down, so that's just going to be 1 year. Okay, the percent is 4%, and then I'm going to simplify that. Cross out divide both sides by 60,000. Okay, and then you're going to have 80,000 over 60,000. On the right-hand side, I simplified that. I got a decimal. So I have 1.04 raised to the t. Our variable is in the exponent, is equal to 1.3 repeating, or 1 1/3. Now we're going to take the log of both sides so we can solve for t. So log of 1.04t equals the log of 1.3 repeating. Put that in your calculator. Okay. Put that exponent out in the front. Divide both sides by log of 1.04. That's going to cancel. T is equal to log of 1 1/3 over log of 1.04. All right, when you put that in your graphing calculator or your TI-84, you're going to get approximately 7.33. It's asking us how many years, so we need to decide how we're going to round that off. So I'm rounding it to the nearest tenth, approximately 7.3 years. All right, now we're going to look at compounding continuously. This is a different formula. So if it says continuously, okay, we're going to start with the initial amount, which is P. For the total amount, to get that, we take the initial amount times Euler's number, E, raised to the rate times T. So it's a little simpler formula. Okay, write this down. A is the final amount. P is the principal, or the initial amount. R is the interest rate as a decimal. T is the time in years. And E is Euler's number. This is an exponential function, is part of the formula. All right, now we're looking at this. The key for this is if you hear or read the word continuously, we're using that formula. Make sure you've got it written down. Hannah wants to invest $970 into an account that is compounded continuously with an interest rate of 5% for a decade. How much money will she have gained from her initial investment? So here's our formula. Okay, A is our initial amount, that's 970. I'm sorry, A is the total, that's the amount gained. Let me look at that, I'm saying it wrong. Okay, A minus 970. 970 is our initial amount, that's P. We're going to subtract that from the total amount, and that's going to be our amount gained. Because it's asking how much money will she have gained from her initial investment. All right, so let's put all of this into the formula to find our total amount. So our total amount is equal to the principal, 970, times E to the rate, which is 0.05, times time, which is 10, because a decade is 10. So that gives us $1,599.26. So we're going to take the amount, the total amount, and we're going to subtract 970 to answer the question. How much will she have gained? So the answer is $629.26. Now let's look at another example. Carol invested some money into an account that's compounded continuously. So we're going to use that continuous formula. Her investment has an interest rate of 6.5%. After 5 years, it's accrued to $1,107. What was her initial amount? Start with the formula. A equals P times E to the RT. Okay, highlight important information. Continuously tells us that's the formula that we use. We need the interest rate, the time, and the initial amount. Plug that into the formula. Okay, we don't have the initial amount. That's what we're looking for. We do have the total amount. So we're going to put in $1,107 for the total equals P. Again, we're looking for P, so that's going to remain our variable. E is a number like pi is Euler's number, and that's raised to the 0.65. We need to change that to a decimal and then multiply by time. Okay, our time is 5 years. All right, so this is what we have. We're solving for P. All right, so we're going to divide both sides by E to the 0.325. Okay, that's going to cancel out on the right. And when you put that into your calculator, you get $799.84. Okay, that's the initial amount. All right, your assignment is the compound interest handout. It can be found in Google Classroom. Complete problems 1 through 10. Show your work. You need Desmos. You need a calculator. You can't do this without a calculator. Or you can use a handheld if you have a TI-84 at home. Either one. All right, good luck. Reach out. Let me know if you have any questions, and I will see you either tomorrow virtually or in the classroom in person.